Hello everyone, I'm Elliot and I am through to this year's final 128 people in the Microsoft Excel World Championships by the Financial Modelling World Cup team. So very excited. On Saturday the 29th, or whatever the final Saturday of October is, I will be in that 1-8 head-to-head round, so I'll be playing against one other person, just trying to beat their score. We'll be given a case and whoever gets the best score goes through. If I go through, then the top 64 playoffs is also that day, with the next two rounds later in that week. So today we're just going to go through one of the old cases. This is a case from last year's final 128 people playoffs. I've not seen this case before. We're going to have a look at this blind with 30 minutes on the clock as if we were doing it on the day. And then we're going to go through at the end and try and see if we can tighten anything up, maybe explain a few things and go from there, maybe compare against the scores of people last year. As I say, I've not looked at this case yet, so we'll start the timer and have a look in a minute. We've got the timer up here. I've got Carnap installed as well down here, so you can see what I'm typing as I'm typing it. Yeah, excellent. Let's get this clock started and let's have a go. Okay, morning round from last 128 last year, The Amazed Mouse. It's by Joseph Palasok. The story. A mad scientist is training mice to learn to solve a maze. There is a 10 by 10 grid. To the right, is it always that 10 grid? 10 by 10? Yes, it is. In fact, actually, let's just hide the answers. We don't need the answers, and we also don't need column F, because we won't have that on a live thing. And we can check at the end if there are specific questions which are wrong. Anyway, there's no thing down here that says mazes, so I'm assuming, yeah, they're all the same. Is that the same? Looks the same. All the same maze. Brilliant. Grey cells are walls and blue cells are water. The scientist is a big fan of the MEWC and other Excel tournaments, so it looks like the does it look like the FMWC logo? Let's just load that up. Yeah. Okay, yeah. I'll let them have that. There we go. There are 100 mice. Cool, looks like it's a mouse per round then, because there's 100 questions normally, plus bonuses. The first mice are not very smart, the later mice are learning from the preceders. They can move up, down, left, or right, so orthogonally, and they can't move diagonally. They can only move where there's no wall, no water. If they try to move onto a space that's occupied by a wall or water, then they... if it asks to the same space occupied, I assume that means wall or water. They will not move and instead stay in the same position as they started. Okay, and let's have a quick read through the questions. I can't read that there. So question 1 is a unique identifier. Question 2 is just a single move. Question 3 looks like it's a set of moves. A set of moves and there's no water and no walls. Question 4, well, this will be the same set of moves then with the walls. Yeah, with the walls and the water. And then this looks complicated. What is this? They can follow the right hand wall. Yep, as you learn as a kid, going through the mazes. Do you remember the mazes? They were fun. Oh. A move only counts as a move with the change location. You get given a starting square where there's only one valid next move and a target square. How long does it take them to get there? Okay, that one's going to be difficult. These other ones we can work through though pretty easily. I don't see any bonus questions. Normally there's 3 bonus questions. No? I wonder if they had bonus questions when they were solving this live. Okay, well let's get started then. Let's spell the word maze correctly for starters. Let's chuck this in another sheet so we're not messing things around. Ooh, that's not as pretty as theirs. Let's make that a bit prettier. Most important thing is that it looks good. Okay. And then we're just going to get a nice little... that's not going to work. What do we want? We want something which is just a nice little identifier of all of those. So that concatenation then will take this, and A and 1 is the first square, B and 2 is like a matrix. Cool. So that's the names of our places. And then we can just do this and say what am I wanting to do? I want to, on this, replace anything that is white within this selection with a fee for valid. And let's choose anything that's blue with water and W, WA. R for water then, because we can't use, because it's the last letter of the word water. We couldn't find anything to replace. There we go. I have no idea why that was complaining there. And then we'll do L for wall. And we'll probably should make a note of that somewhere, because otherwise I will forget. Valid water wall. There we go. Okay, so let's just use toCol. So toCol will just take an array and it will make it into a column. And you can even do toCol. You can use these different arguments to make it scan by column first, so you get all the columns through. We're just going to leave it as that, because that will be faster for typing all the other ones. Less typing is good. And now we can do the exact same thing with this to get whether it's a wall or water. And of course this doesn't have our outside boundary, but that's fine. F3 somehow was missed there. Okay, everything else looks good. Cell type is valid move. So that's simply going to be, is that equal to fee? So the hashtag just lets us pull in that entire dynamic range. And unique identifier. And our unique identifier was row number multiplied by 10 plus column number. Okay, so we're going to use let, which lets us basically name things as if we're doing things as a function in Python or something, or Excel or VBA or whatever. And we'll call this a cell reference. So that's our variable name. I'm going to use the indirect function. So indirect lets you take a cell by its name as opposed to the cell. So it's not selecting P2, it's selecting the cell named whatever it is in P2, which is A1. And then we should be able to do the row of cell reference times 10 plus the column number of cell reference. Is that times 10? Okay, cool. And let's just pop that there, 102. And I just want a nice little X lookup. So X lookup is just like VLOOKUP or HLOOKUP if you've not seen it before, but it is easier to get your head around. And you also don't have to deal with any of that nonsense about things being before or after. So it'll let us look up both ways. So we can look up in S2 and then return in P without it being before it. You can also set a default not found value. That's not important here, but it might help us later on. And there we go, 60 points on the board. Let's make a model for this. Let's just call it level 2 for now. So I normally cheat these a bit and use an index, and starting cell is going to be the index of this by B1. And what column is the movement in? The column is I. So we can just copy that whole thing down here and change this to an I, and we've got our movement. Okay, So first we need to know is it a horizontal movement? So that is simply an or for this being R or L. Movement amount. So that's going to be very similar to this. So that's going to be if it is a right or a down, it's a +1, otherwise it's a -1 because it's going up or to the left. Starting row is just the row of is indirect again. That. Starting column is going to be the same thing but with the column around it. Okay, that's our starting column. In which case we then need to say movement row, which is going to be our row plus if that is true, nothing, otherwise our movement value. That's our movement column. So that's going to be our starting column, and then these are going to be reversed. Here we go. Is within bounds. So that's just checking that all of these things are true. So that is greater than 0, that is less than 11, that is greater than 0, that is less than 11. Is it a valid move? So that's just going to be, we need the unique identifier. Move to unique. So that was row times 10 plus column, wasn't it? So now we're just going to look that up in our thing, and this is what I mean, you can look backwards with these, which is great. I've got a plus on there somewhere. Okay, so that's not a valid move. Can move, so that's just going to be both of these things need to be true. Result square. So if that's true, then it's looking that up. In here and returning this, and we can lock those, and if it's not true, then it is our starting cell. Okay, and then we're just going to make this equal that. I'm going to have a sequence of, how many questions are there? 20 questions. Starting at 3 because we've got 1 is here, 2 is here, and 3 is here. And then we can use a what if table. So if you've not used this before, they're very powerful. They basically let us do all these calculations at once without having multiple rows and columns. We could, and now it's asking what the column input cell is. So it's asking where these columns are going, and they're going there. And that is giving us a 0, which means that automatic calculations are turned off, or it's far too complicated for it to do. Ooh, NAs. Ooh, that's not right. 18. Starting column is 6. Right. So in this, we need to return if it's not found. So if it's trying to look this up and it doesn't exist, we just want to return false, and that should then give us a full set of answers. We will, for now, assume they're correct because it gave us the correct answer for the first one. I'm just going to duplicate this and do level 3 and 4. So level 3, let's put this back to 1. Level 3 is just this. And this time we're going to have to use choose rows to get the full first row. And doing it this way hopefully will mean that we can just do the whole thing at once. Ignore internal. So for level 3 we want to ignore those internal walls, don't we? So that's if it's a valid move. If that's true, well, we can just set that as an or then, can't we? So it's that or that. Basically, if this is true, then it's always going to be true. If that's false, then it depends on our lookup. And then which of these need locking if they aren't already. These all look fine. That's locked. And then this is just going to be that. Pull this across to the end of our 30 moves. Pull these across to here. It says F8, so what's going wrong here? J6. Moving left, moving onto the water, but that's fine. It's I6. I know, it's this. Here we go. Is valid move. That needs to be locked. Nope. Left, left, right. Just pull the maze in here for a second. In fact, let's just pull this one in. This one doesn't matter. J6 goes left, left goes right, goes down, goes left, goes right, go down. I8 goes left, goes right, goes right. Ooh. Goes left, goes right, goes right. Doesn't move. Goes left, goes left, goes left. I'm an idiot and I've pulled in the wrong thing here. J6, is that right? Okay, what's going wrong here? J6, we should end up at F8. J6, we head right, so we stay on J6, we head left, so we head to I6, we head up, so we head on A5, right, so we head up on A5. Have I got all 30 in here? Yep. I6 to I5 to J5 and stay on J5, go left I5, go right to J5, go left as A5, go down I6, go right, go left, go up, go up, go up, go down, go down, go down, go left, go right, go left, go left, go right, go left, go down, go down, go down, go left, go up, go left, go right. Ah, I am a total idiot. Wasted so much time because I didn't move the answer cell. Okay, right, that should be those. And then level 4 should just be a case of changing those references and changing this to false. J8, that's the same as our test case. Okay, now the hard one. Okay. Don't know if we're going to get much of this hard one done. Should we just do one manually? So C1's the one that they started with, so where are we going? 8, 6. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 plus 27 is 44. Okay, right, I think I understand what I'm doing. Gonna make it pretty. Okay. I'm gonna need a few mazes here. I don't know how many I need. How many unique starting places do we have? Ooh, I am running out of time. Okay, that makes sense. Does that make sense? A tenth of the places. I don't know. Maybe I'm talking nonsense. Okay, let's highlight these then, if they are a starting cell, just so we know where we're looking. So that's going to be that and that, and we want to know, is that a number for X match? So X match is basically the same as match, but you don't need to tell it that you want an exact match, because I always forget how that works. And then format, let's just make it a nice bright yellow. Okay, there's our starting cells. Okay, well, we're going to need 10 of those then. 1, 2, 3, 4, 5. 10. And what order do they go in? So I've got an idea for this. Basically, looking at this, you don't repeat until you've been someone and you come back, I think, is how it works. I hope that's how it works. We've only got 10 minutes. So we're going to start here. How does it work? That's a 0. So we're going to go 0, 1, 2, 3, 4, 5, 6, 7. Except we're going to do it in this one. 0, 1, 2, 3, 4, 5, 6, 7. And this next one is going to go 0, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There's probably some smart, clever way of doing this with circular references, but I don't have the time to work that out. That's not right. 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 26, 27, 28, 29, 30, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7. Okay, then we can get our list from our maze of our cell names. And this is the distance from, what order do they go in? C1, A2, A10, C10, no, C8, C10, E10, H10, J10, E5 and H1. I think I'm going to want some calculations up top, so let's just move these down a few rows. And then we're going to use our friend to call there, and just move these around. I don't know if this is going to work, but we shall see. Again, there's probably a fancy way of doing this, but I don't have time to work that out. I've got 5 minutes left. Okay. Right, so if it wants to come to here from C1, let's come all the way around to here and then come down. So from C1 to somewhere on A2's path, we need the whole run of C1. So let's get the full run of the path from there. So let's try this again over here. So these are the answers from C1. And that is that's just simply if that isn't 0 in itself, otherwise 0. That's not quite what I mean, is it? So if that is greater than 0, then it's this plus that, otherwise it's 0. If that is greater than 0, then it's the sum of those two, so we can lock that first one. Okay, that's what I want. Right, that's what I want, so I can do that way, and I can do that way, and I can do that all the way down. Okay, so that's our C1 answers in, isn't it? From C1. What are places that repeat? Where's the place that repeats? A3. So it should be 6. So it's the minimum of that row. That's not right though. Okay, right. So that needs a locking on the row. Okay. Okay, so at the minimum it's not 0. That's what we want. Okay, well I think that's our answers for C1. But then we need to shift everything. Okay. So it's A2, we want to start from here, but then we want to wrap around and so on. So let's just duplicate it all. So that is that. There we go. Okay. So that just duplicates it all. And the reason we want to duplicate it all is because we want to do this for each starting place. So this is just going to be, call that C1 there. Okay, so this is looking that up in there. We're running out of time here. C1, C1. We just want a place that's there. Okay, right, let's whack these answers in here then. So let's just take the fact that we've got it right for the C1s. I've not actually checked that, but we can hope. Let's just do that then. That's 44 cells, that's good. That didn't work. Okay. Right, there we go. Okay, that's my final answers. Time is up. Dismiss. Okay. Right, let's see. Score NA. Okay. Why is my score NA? What was my score NA? What have I done? I messed that up somehow. There we go. Oh, good to see that's right. 676 was that score. Okay, shall we have a look at how that compares to people that actually did this case? So, last year's rankings. We want the full rankings, please. And this was the morning session. So that's the yellow lots. 676, there we go, same as world seeder number 1 at the time. I'll take that. 664, 664. Okay, so where else is morning sessions? Okay, yeah, no, feeling good about that. Quite a few people getting 676, but no one getting over that, which suggests to me that they didn't have bonuses. I'm just going to finish this up and see if this does give us what we expect. So my clever way of working this was going to be we're going to take this. I'm going to take this. And we're just going to have this returning the first C1. And then we're just simply going to offset that. I know we don't like the offset function because it is a volatile function, which means it can change what it's doing without, just like the random function, it doesn't need a cell reference to update, so it just updates every single time anything changes. But that's fine because we're not going to use it too much. So we're just going to offset that by 1 column. And in fact, I'm just going to call this sequence. There we go. And instead of doing that, we'll just do this, and that will give us our row there. And then we're just going to take this again. In fact, that can be a 0, and then they're all behaving. They're all behaving. There we go. Now we'll take this again, and actually let's pop this out. I think I've been doing about a minute so far extra, but should have done this. See how much extra time it takes us. So this time we're going to return the column from this. shout at me. Shouting at me is fine. And we're going to look up this point so you can see what we're doing. That needs to be locked. Where's CV3? CV3 is fine. That one wants to move. Cool, so now if this says, what was our starting cell again? I've lost the thing because the camera's there. H6. We need the sums in there. So let's make this let file, and if file equals 0, 0. Otherwise it's the sum of offsetting those. This is complicated, so I shall talk it through in a minute if it works. Well that's not worked. C1 to H6, H6. It's this one here, so it's got a 7 and a 4. It's got a 7 and a 4. So let's see. So that is 37. Right, these want offsetting by this one needs to be locked to CV2, CV3. It's still not right. We want that offset by 0. That's 37. And we need the file in there as well. I see. Okay. And now we're going to do one of the complicated fits. So that's just going to be those names. That's just going to be this here. And then when you're doing a two-way what if table, you use the corner like that. We're going to do it. It's going to shout at me. This is a lot of calculations. So our column input cell is that one, and our row input cell is that one. Oh, I didn't show that me too bad. And let's just have a look and see if that works. Looking that up in there, and looking that up in there, and we're returning the whole lot. Lock those. Okay, that did not work as expected. Which one is it breaking for? Shall we have a look? H1 from for E8. H1 to E8. What's the actual answer? Let's find out in a minute. E8, let's see if we can debug this first. E8 is (12) from A10, but we're not starting to H1. So it's 12 from A2, 12 from, okay. So for H1, you have to go all the way to C1. So that's 22 squared. So it's 34. So why are we getting 43? Let's just call that answer for a minute. And let's just do this. (31). Okay, well, let's work out what's going on here then. What's that actually returning us here? Oh, it's giving us 7, 8 and 16. Okay, right, so we need an X match of this in here. And then this needs to be that one. That's giving us 43. Still, which isn't right. From H1. So let's see. (7, 8 and 16). That needs a -1 on it. Is that all we need? Is that all we needed? Let's have a look. There we go. Okay, right. No way that was going to get done at the time. Took a whole extra 10 minutes, but that's fine. Let's talk through what we've done. Sorry for going all quiet on you there. There we go. Okay, so what did we do? Well, first of all, we took this maze. We did a dynamic range concatenation, basically like a vector product sort of thing. So this is just doing A times 1, B times 1, C times 1, although we're using AND for the concatenation here. And we've also labelled what each of our things are in here. I thought we might need to know what was water, what was walls, but turns out we didn't, so that's fine. We used the toCol on this to get the names of all the things, and because everything is set up the same way, this is set up the same way, we can then use the same function to get things in the same order, and that means that we know what type A1 is and whether or not it is valid to move to it, aka is it not water or not a wall. And then we have that unique identifier which is defined there, and then we simply use XLOOKUP. So XLOOKUP, you put in the lookup value, the lookup array, so in this case we are looking up in P2, so we're looking at the name, and that hash number here, that hash symbol, which is also seen here just says take that whole dynamic array, the array that starts from there. So if this increases or shrinks, this will increase and shrink with it. So for example, if we do this, you'll see that changes this just to go to there. That will also affect our lookups. And then it returns it, so that's easy. Level 2, a little bit more complicated because you've got the movement, so we get the starting set. We use an index just so we can use this at the end. That's just a little trick. So we can use the data table. The starting cell, it uses that index value. The movement direction uses that index value just to get it from the case. So that reacts to this. This checks whether we're moving left or right. This checks whether we're moving right or down. So if you're going right or down, then you're moving across 1 or down 1. So that's +1 on your direction, -1 for going up or left. We get the row and column from this. We then add this to this if it's a vertical movement, and if it's not, we add it to this. So that's these two and these two. We then check that this is within the bounds, because you could end up outside the maze, but there are external walls there. And those external walls, because of the way this ×10 + 10 thing is working, I think if you ended up outside the maze, you could end up getting a valid cell reference number, but that's valid cell reference number then isn't a valid number because you can't actually move that square, but it would think you could because it would think it was within the maze. We get the unique identifier. We use the XLOOKUP to look that up in the maze, and just in case that's not a valid answer, which sometimes it's not, we use this if not found argument here. So we just tell it that it's false, it's not a valid move. Can move, it's just, are both of these things true? And then if that's true, then we look up what the unique code is as a name. If it isn't true, then we just take our original starting cell. And then this data table just works all this out for us. So the data table, if you're doing a one-dimensional data table, you have your column or row there or across, and your equation here. Our equation simply is just referencing this cell, and we told it that the column input was this index because that's the one we changed to get the different answers. It can't be 2 because 2 is a blank cell, but there we go. That's going to give us our answers now as we go through down here. D6, D6, there we go. Levels 3 and 4 were basically doing this repeatedly, so we scaffolded that out. We can do them both in the same set of equations because one is just ignoring the walls and one isn't, the internal walls. So this now is using choose rows to get the whole row from this input and that starting cell. We go through that normal set of calculations. We reference the ending cell as the starting cell for the next round, and then we just do that all the way across. And then what I was forgetting to do at the end there was I forgot to actually change this result square to be the final square. I was still taking that end of the first move, which is why I couldn't get it to match this. It's still not matching that because this is set to level 4, so there we go, there's level 3. And the only difference between 3 and 4 is this being true or false, which is this or equation here. So if it's true, if we're ignoring internal walls, then yes, it's a valid move because we're not checking within the bounds anymore. That's done here in row 13. And if it's false, then it's true if this is true. Yeah, that's the or statement there. And again, we use a data table for both of those. And then level 5, this we didn't do in the time, but it looks like from the scores nobody managed this in the time on the day, so that's fine. So I'll just walk you through what we did, because we did get it working in the end. As you can see, they're all right. It took us an additional 10 minutes over the time. But first of all, I just copied the maze in. I got a list of all the starting cells just to find out where the starting cells were. So there's 10 of them, so we made 10 maps. And they are ordered in the order that you'll hit them if you're going around. So the thing about going around this maze, probably on the right hand side, is as you can see in that example that they gave, there are some cells where you double up. You'll even triple up on some cells, because you're going to hit this one on your way back from here as well, and you're going to get around there. But you're only going to double up. You don't double up within a single segment, if that makes sense. So you go round to here, and then you don't double up until you leave here, which is basically like starting from another place. So we've got each of those starting places going in order as if you're going around. So you're following the right hand side. So you start here, you end up here, which is what we've done here. And then you're here, so you come all the way down here. And then you come up and you end up here. And you go down to this one, nice short journey, another short journey, a bit of a longer one, a long one all the way around to here, a very long one around to here, up to there, and then you're back where you started. So it's sort of cyclic. And then initially we were just building it out for the C1, and we got the C1 answers within the time with I think about 3 seconds to spare, which put us among the top people for this session on the time, although it is always a lot easier when you're not doing it live. So what are we doing here? So this is just our list of cells using the 2-column thing from before, and then we've got each of the starting cells, and this is just how many moves it is to get to each of those from there. We've duplicated this out because of the way the questions are, but we'll come back to that in a minute. So we can just ignore this here because this is just a duplicate of this. And then on top is how long is the full path until you get to the next segment. So we're going to use that later as well. So that's length of segment. There we go. Make it pretty. Cool. And then what we do is we've got a nice little data table here. This is a two-way data table. So for a two-way data table, you have a row input and a column input. Our column input is this cell, it's the cell we're looking to get to, and our row input is this cell, it's the row we're starting from. And you just put the equation here. We don't need these now. That was when I was scaffolding it out. You put that equation here, you make the data table, and you get all the answers. I was worried it would be a little bit too slow, but it seems to be alright. If it were too slow, one of the things we could do to speed it up is just reduce this down to only being answers that are actually shown here. That would have reduced it somewhat. So instead of having 100, obviously it's 100, we would have had there we go, 27, not even 30. So what did we do? So let's set this to C1, so that'll be easier to explain. And let's set that to the first one that's non-null. Let's set it to itself. There we go, 106. So what? Actually, let's just set it to their example because we can follow that around. Let's bring this in. 27. So what's that? E8. Okay, so we're starting at C1, and we go around and we hit A2. So we do a full loop of C1. So this is going to be 0 because this is 0, and then this looks up. Let's just talk through these things here. So this X lookup looks up this value, sorry, this value in this column, and looks up this value in this row, and returns whatever the intersection is on this whole table. But we're using an offset here, so this offset, I'm trying to remember what I did now, this offset offsets whatever you've returned by whatever number is here, number of columns. So that's how we get C1 here, basically the C1 result, the A2 result, the A10 result. This here is just doing that more simply, so it's looking up for the first occurrence of C1 in here and returns it, offset by 0, this one returns it by 1, and this is because we leap around. So starting from C1 was easy enough to calculate, but if you wanted to start from A10 and go to somewhere that you only reach in A2, then you have to go all the way around the maze, hit C1 again, and then go through A2, which is why we've got this pulled out twice. And that's the longest you'll have it, because if you're starting at H1, then you're going to go all the way around to E5, and then you're back at C1 again as your starting cell. So we didn't need to do it any more than that, so just one repetition. So this basically says that if this is C2, not C2, what else is on there? A2. then we're going to start by looking in the A2 column and then the A10 column and so on. If this is H1, we'll start by looking high. There we go. So H1, we'll start by looking in this column and then we'll go through in this order. So that's basically what that is doing. This then returns whatever the correct value is for one of these. If it is 0, then it stays at 0. If it's not 0, then we get the sum, we get the value that it's showing, and we add that to the sum of all the paths it's had to trace before. So that is basically an expanding, just by locking the first one, just by locking the first thing, it's the expanding row across here, and then that's offset by however many our starting cell is. So this is a 4. It's just being slow. Cool. So this is 0, so we don't want to offset it at all. So it's X match is going to return 1 because it's the first one in that row, and we're going to take 1 away from it to be 0. If this is A2, this will be 1, and so on and so on. But basically we want to offset this this sum by however many. So you're starting at A2 and you're going however far across. And that's basically all this does. So it works out every time you hit it. So you're going to hit it, if we could put this back to our example, because we've got that in front of us, you're going to hit E8 at 27, and then you actually hit E8 again at 39. So you come down here, you go around here, down here, up here, down here, hit it again at 39, but we take the first time we hit it, so we take the minimum value of this where it's not 0. We could use a filter function, but minifs I think is a little bit faster. So if we set this example, for example, to, what's this, A5, we'll see quite a few values, because A5 you hit it there for 10 and 20, and then indeed you hit it again as you're coming up from here, back round to here, at number 84. And then this table is simply looking up this value for this changing to each of these, and this changing to each of these. And that did it. As I said, it took us a little bit longer than planned. It took us an additional 10 minutes, but we were able to get the C1s structured and sorted within the time, which looks like that's all anyone managed to do in the time. So feeling quite pleased about that. That's me been nattering on now for an hour. So there we go. I'll be trying some of these other ones in the next week or so, in the lead up to the next stage. Just getting some practice in. Hopefully there are a couple of easier ones. This afternoon session is the one that was broadcast live last year. So I've not watched the video, but I've watched it enough to see that it wasn't this session. It was something to do with connections. It looks like it was a little bit harder, a little bit easier. This was a very hard session, very hard case. But what do you expect? Final 128s. We'll have a go then another time at that one, and try and work through some of the others as we go through. Anyway, there we go. Thanks for joining me.